While many people focus on the potential wind damage from a hurricane, more people are actually impacted by the force of water as a storm makes landfall and moves inland. These water impacts are storm surge, as seen here, and freshwater flooding. Along the coast, storm surge is often the greatest threat to life and property from a hurricane. In the past, large death tolls have resulted from the rise of the ocean associated with many of the major hurricanes that have made landfall. Hurricane Katrina in 2005 is a prime example of the damage and devastation that can be caused by storm surge. At least 1,500 people lost their lives during Katrina, and many of those deaths occurred directly or indirectly as a result of storm surge. Storm surge is an abnormal rise of water generated by a storm over and above the predicted astronomical tides. This rise in water level can cause extreme flooding in coastal areas, particularly when storm surge coincides with normal high tide, resulting in storm tides reaching up to 20 feet or more in some cases. Storm surge is produced by water being pushed towards the shore by the force of the winds circling around the storm. The water is pushed onto the shore, and the maximum potential storm surge for a particular location depends on a number of different factors. This is because storm surge is a very complex phenomenon and is sensitive to the slightest changes in storm intensity, how fast the storm is moving, the storm's size, angle of approach to the coast, central pressure, and the shape and characteristics of coastal features such as bays and estuaries. Other factors that can impact storm surge are how wide and steep the ocean floor is along a coastline before dropping into the deep ocean. This is called the continental shelf. A shallow slope, as seen here, will potentially produce a greater storm surge than a steep shelf, as seen here. For example, a Category 4 storm hitting the Louisiana coastline, which has a very wide and shallow continental shelf, may produce a 20-foot storm surge, while the same hurricane in a place like Miami Beach, Florida, where the continental shelf drops off very quickly, might see an 8 or 9-foot storm surge. Adding to the destructive power of surge, battering waves may increase damage to buildings directly along the coast. Water weighs approximately 1,700 pounds per cubic yard, which is about the size of a kitchen stovetop or oven. Extended pounding by frequent waves can demolish any structure not specifically designed to withstand such forces. The two elements work together to increase the impact on land because the surge makes it possible for waves to extend inland. Additionally, currents created by tides combine with the waves to severely erode beaches and coastal highways, as seen here. Buildings that survive hurricane winds can be damaged if their foundations are undermined and weakened by erosion. In confined harbors, the combination of storm tide, waves, and currents can also severely damage marinas and boats, as you can see here. In estuaries and bayous, salt water from storm surge endangers the public health, kills vegetation, and can send animals such as snakes and alligators freeing from flooded areas. In addition to the storm surge and high winds, hurricanes threaten the United States with their torrential rains and flooding. Even after the wind has diminished, the flooding potential of these storms remains for several days. Water accounts for about 90% of direct deaths associated with hurricanes and tropical storms. Of that 90%, almost a third of U.S. tropical storms and hurricane deaths are caused by people drowning during freshwater flooding. Most of these fatalities occur because people underestimate the power of moving water and purposely walk or drive into flooding conditions. In the last 3 hurricane seasons, over half the deaths were vehicle-related from people trying to drive through flooded streets. Don't underestimate the power of water. If you see a sign that a road is closed, remember the saying, turn around, don't drown. It is common to think that stronger storms have a greater potential for flooding. However, this is not always the case. A weak, slow-moving tropical storm can cause more damage due to flooding than a more powerful, fast-moving hurricane. This was very evident with Hurricane Harvey in 2017, as you can see here. Harvey devastated portions of southeast Texas, including the Houston metro area and surrounding communities, with severe flooding. Harvey was the most significant tropical cyclone landfall event in United States history, both in scope and peak rainfall amounts. While Harvey first made landfall as a Category 4 hurricane, its winds quickly decreased to tropical storm strength as the storm's motion slowed, and Harvey spent 4 days over southeast and east Texas and dumped record amounts of rainfall across the area. A record of 5 feet of rain was recorded in some cities, with many areas recording over 3 feet of rain during the 4-day period. So remember, water is one of the most dangerous threats from hurricanes.